Imagine that somewhere on the other side of the world, a missile suddenly erupts from its launch pad. Within seconds, before it has traveled very far, America already knows. Not because someone saw it, not because a pilot reported it, but because an invisible network of satellites and radars has been watching the planet every second of every day. A system so advanced that it can detect the heat of a missile launch from thousands of miles away. Tonight, we're taking you inside one of the most secretive and important missions in the United States military. From giant radomes hidden in Colorado to satellites orbiting 22,000 miles above Earth, this is the story of America's missile warning mission and how a few critical seconds could make the difference between peace and catastrophe. For most of human history, armies could see danger coming. A fleet appeared on the horizon. An army marched toward the border. A bomber crossed the sky. There was time to react. But ballistic missiles changed everything. A modern missile can travel thousands of miles in less than an hour. Some travel at speeds exceeding 15,000 miles per hour. That means a nation under attack may have only minutes to understand what is happening and decide how to respond. The challenge is obvious. How do you detect something moving that fast? How do you know where it came from? How do you know where it's going? And most importantly, how do you know about it early enough to do something? The answer is a global warning network built over decades, a network that never sleeps. That never sleeps. The first layer of missile warning doesn't sit on Earth. It floats above it, thousands of miles above it. The moment a missile launches, something remarkable happens. Its engines generate enormous amounts of heat. That heat creates a powerful infrared signature. Think of it like a giant flare in the darkness. And that's exactly what missile warning satellites are designed to detect. Unlike ordinary cameras, infrared sensors don't need visible light. They see heat. As soon as a missile's engines ignite, the sensors recognize the thermal plume. Within seconds, computers analyze the event. Is it a missile, a rocket launch, a false alarm? The system rapidly compares the information against known patterns. The goal is simple: detect the launch, confirm the launch, alert decision makers, all in the shortest time possible. This capability allows operators to observe vast portions of the planet simultaneously. No matter where a missile is launched, there is a good chance that someone is watching, not through a telescope, not through binoculars, but through some of the most sophisticated sensors ever placed in orbit. Once a launch is detected from space, another system begins its work. Radar. Colorado is home to some of the most recognizable structures in America's missile warning architecture. Massive white spheres known as radomes. At first glance, they look almost alien, like giant golf balls dropped onto the landscape. But hidden inside these protective shells are highly sophisticated radar systems. The radome itself isn't the radar. It's a protective cover. Its job is to shield sensitive equipment from wind, snow, rain, and extreme temperatures. Inside, powerful antennas scan the sky. Their mission is to track objects far beyond the atmosphere, thousands of miles away. These radars help determine critical information: how fast an object is moving, its trajectory, its altitude, and whether it represents a threat. The combination of radar tracking and satellite detection creates a much clearer picture than either system could provide alone. One sees the launch, the other follows the journey. Together, they form part of a global warning network. Operation centers, personnel monitoring screens, communication systems. Technology is only part of the story. Behind every sensor, radar, and satellite are people. Highly trained operators work around the clock. 24 hours a day, 7 days a week, 365 days a year. The mission never stops, because missiles don't wait for business hours. Inside operation centers, personnel monitor streams of data arriving from sensors around the world. When an alert appears, analysts begin verification procedures. They examine multiple sources, compare sensor information, confirm the event, and communicate the findings to higher authorities. The process is designed to be fast, but also accurate, because mistakes can have enormous consequences. Every warning matters. Every signal matters. Every second matters. Maps, command centers, communications networks. Detecting a missile is only the first step. The information must move quickly. Very quickly. Once a launch is confirmed, warning data is distributed throughout a secure command and control network. Military commanders receive updates. National leaders receive updates. Defense organizations receive updates. Everyone involved needs the same picture of what's happening. The objective is not panic. The objective is awareness. The faster leaders understand the situation, the more options they have available. Whether the event is a routine rocket launch, a missile test, or something far more serious, accurate information becomes essential. In the world of missile warning, knowledge is time, and time is everything. The missile threat continues to evolve. New technologies are emerging. Missiles are becoming faster, more maneuverable, and more difficult to track. Some modern systems are specifically designed to complicate traditional warning methods. As a result, missile warning systems must evolve as well. New generations of satellites are being developed. Sensors are becoming more capable. Computing power continues to increase. Artificial intelligence is beginning to assist analysts in processing massive amounts of information. The mission remains the same: detect threats early, provide warning, protect lives. But the technology required to accomplish that mission continues to advance. Earth from space, radar domes at sunset, satellite imagery. When most people think about national defense, they picture fighter jets, warships, tanks, and missiles. But one of the most important defensive systems rarely appears in the headlines: the ability to know, to see, to detect, to understand what is happening before it is too late. From satellites orbiting high above Earth to giant radomes standing watch in Colorado, America's missile warning network represents decades of technological innovation and constant vigilance. Most days, nothing happens. And that's exactly the point. Because success in this mission isn't measured by what people see. It's measured by what never catches them by surprise. And somewhere, right now, as you watch this video, the system is still watching, still scanning, still standing guard. If you enjoyed this deep dive into one of the most important missions in modern defense, make sure to like the video, subscribe to the channel, and turn on notifications so you don't miss future episodes. Until next time, stay curious, stay informed, and thanks for watching.